Okay, so I believe most of this should be somewhat of a review or a reminder. Exponential, we'll call it. Okay. So we're doing exponential functions. Who remembers what an exponential function is, what the form is? Can someone take a guess? So we know, yeah, go ahead. X squared? Close. And I see, because it has an exponent, so I know where you're getting from. So it is in the form of y is equal to the power, y is equal to b to the power of x. So instead of basically, you add x squared, you basically, you're swapping it. You want your exponent to be your x value, and your constant to be your b value, or a few rules for this. My base, which I'm calling b here, it has to be greater than 0, and b cannot be equal to 1 for it to be considered exponential. The reason why is if you do b to the power, or b is equal to 1, 1 to the power of anything is 1, doesn't really go anywhere. Also, if b is greater than 1, it's exponential growth. And if b is greater than 0 but less than 1, exponential decay. So just as a heads up, the examples we go over today, they're either going to be examples that you see on the homework tonight or similar to, or examples that you'll see on the quiz that you'll be taking, I believe, next week. Or a short quiz or something like that. So if we graphed y is equal to 3 to the power of x. She calls them the Fab Five, right? Like -2, -1, 0, 1, and 2.
Yeah.
Yeah. So just by looking at this, what kind of, is this a growth or decay? Growth, greater than 1. My b value is greater than 1. But we'll see. So 3 to the power of -2. -2. 1 over 9. Because I plug in my -2 to x, or x, -2 into x. Negative makes it down to the denominator, then 3 squared, so 1/9. If it's a negative, then basically whatever on my base is, they switch. So if this was like 1/2 to the power of a negative number, then it becomes a whole number. But for this case, yeah. So 3 to the power of -1. 1 over 3. 1/3. 3 to the power of 0. 3 to the power of 1. Yeah. Any number to the power of 0 is 1. So then as far as our graph, so if I graph it, -2 to the 1/9 is roughly here, to the 1/3, 0, 1, 1, 3, 2, 9. So basically, it's a growth just because as my x values get larger, this number is going to get larger at a exponential rate. Because if you think my next one's it'll jump from 9, and then 3 to the power of 3 is 27, then 81. So it's going to spike up higher, or it'll rise faster going up than it does right. If it was decay, my graph would actually start dropping from this side and then getting closer to 0 as it goes, as my x values increase. So another example of an exponential function is compound interest. Does anyone remember what that one looks like?
Increases every year. Right?
Yeah. So that one, basically it is something where if I put money in, if it's compounded, if I have compound interest, then if I had $100, 10%, after 1 year, I'll make $10, so 110, and then it's compounded on the 110. So actually compound interest is better just because it compounds off of what you've earned too. Compared to simple interest, it's just off of what you start off with. But for this one, it's A, so like my outcome or my final amount is equal to P, so my starting amount times 1 plus my rate over the number of times that the interest compounds in the year, to the power of my time times n. So it's my initial, my rate, number of times per year. So we're gonna try a compound interest problem. Hopefully. Okay. What have I had for? So Jason puts $500 of his paycheck in the bank. The bank compounds interest quarterly at 3%. How much will Jason have after 7 years? So what is my initial? 500. What about my rate? 3%, so in decimal form?
So point
0.03. How many times per year?
4 times.
4 times, because it's quarterly. And lastly, my time. 7 years. So if we just plug that into our equation. So first thing I do is the rate divided by my n. So 0.0075 plus 1. Any questions on compound before I move on to the next? Nope. So, biggest thing is just make sure that you remember how many times it's compounded within the year. If it's just once, that's over 1, so it's annually. Semi-annually, so twice, it all will affect basically your outcome. So make sure you keep these consistent. Make sure you find out the 4 things you need to find out in order to answer that problem. So who remembers geometric series? Who can tell me what a series is? Nothing? Okay. So there's 2 things that, from either geometric or arithmetic that I believe was covered in math 1 and maybe in math 2 also. But arithmetic is basically it's a sequence where if you're adding a constant number every time. Geometric, you're multiplying a constant number every time. So an example of a geometric sequence is 1, 2, 4, 8, 16. Because what am I multiplying every time? 2. In order to find my geometric rate is, so call this R. It's, you basically take your second term divided by your first term, or you could take any term and divide it by the previous one, and that's how you'll find your R. The explicit formula for this is G sub n is equal to G sub 1 times R to the power of n minus 1. And just as a refresher, for explicit, as long as you know your first term and your rate, you could find any other term. So for example, two, 6, 18, 54. So, for this one, we have a table. This is kind of similar to what your homework will look like, where my first term is 2, second term 6, so on. I want to find my 11th term. So first, what is my rate equal to? So what am I multiplying each time? 3. My first term is 2. So if I wanted to just write the formula for this, it would be G sub n is equal to 2 times 3 to the power of n minus 1. Next, as it says, I'm trying to find my 11th term. So if I'm trying to find my 11th term, my n is equal to 11. This is equal to what? 108,000? 118,000. Cool. Thank you. So again, fun thing about explicit is that as long as you know your first term and your rate, you can find any term. If I asked to find the 100th term, you can. I won't, but if asked, you could. So another way you'll see it written out is kind of like in the first example I gave, where you don't necessarily see the table that says first term is this, second term is this, but you'll just see a chain of numbers with like dot, dot, dot going on, which means it continues on. So for this case, what is my first term? 80. What about my rate?
2.
Not 2. Not 20. Not 10. 1/2. Because again, if I take my second term divided by my first term, so you go to 1/2. For geometric, also for arithmetic, but geometric, since we're covering that, you never divide by a number. So if this was this is technically divide by 2, but in geometric terms, you always say you're multiplying by 1/2 or instead of dividing by 2. So my explicit formula looks like g of n 80 times 1/2 to the power of n minus 1.
Wait, I'm actually not confused. Why didn't you always want to
Here?
looks like the
So geometric is just one of the rules is you're always saying you're multiplying, because if you're saying, oh, I'm multiplying by this or dividing by this, the context you get really confused. So if you always just say I'm multiplying, if it's increasing, I'm multiplying by 2. For this case, I'm multiplying by 1/2, because 80 times 1/2 is 40. 40 times 1/2 is 20. So saying you're multiplying by a fraction is basically saying, it's almost like saying you're dividing by that denominator of that fraction. I want to find the 9th term. So g sub 9 is equal to 80 times 1/2 to the power of 9 minus 1. Which is equal to what? What's 1/2 to the power of 8? And then times 80. 5 over 16. Yeah. .3125 works together. So for example 5 and 6, I'm going to make you do it on your own just to see if you connect the two. But we will come back at the end to see what everyone got. Yep. So for this one, my first term is 1/2. My rate, it's 2 divided by 1/2, so you go to 4. If you wanted, you could just do 8 divided by 2. Either that works. That is a little bit easier because you're not working with fractions, but either way. And my explicit formula then, it's 1/2 times 4 to the power of n minus 1. What about for example 6? 0.0128. Let me see what that is. Fraction form. 0.012, yeah. Which is also equal to 8 over 625. Same thing, my first term this time is 25,000. My rate is what? 0.2, 1/5. Okay. Any questions? So that is it. I'm gonna come around and stamp. I think worksheets 55 and 56. The homework. It's page 697, numbers 1 through 6.